Types of solar panels. In this session, we're going to be talk about what are the different types of solar panels are available whenever we want to design the solar home systems. So basically the solar panel is the very main part of the designing of the solar home systems over here actually. So basically in a solar panel, the number of cells are connected in the series combinations over here. So basically for constructions of the solar panel, we require the solar cells inside the solar panels actually. So like that, according to the size and wattage capacity of the individual solar panel, the number of cells that we are using for connection in the series combination, that is getting changed over here actually. So whatever the utility scale solar panels are available, that are available from the 250 watt peak up to the 550 watt peak over here actually. And whatever the smaller solar panels in the capacity has been available, this we can get in the market from the 30 watt peak up to the 250 watt peak. We can just easily get this corresponding panel. As good as the number of cells that we are connecting in the series combinations are more, simultaneously the voltage, that is a maximum power point voltage and maximum power point current of the individual panel, it is also greater in the such case actually. So basically the selections of the solar panel is only and mainly depends upon what wattage capacity we actually are designing the corresponding solar systems over here actually. For the lesser kind of the capacity, we require the lesser sizing of the solar panels. Some cases we are taking the utility scale solar panels, but the number of quantities we are changing over here. So we're going to discuss that parameter, how we're going to select the panels according to the designing in further in the subsequent lectures over here. In this session, we're going to be talk about what about of the different kinds of the solar panels has been available over here. So the first popular panel has been available is the polycrystalline solar panels. It means what? The solar panel which are made through the polycrystalline solar cells actually. So whatever the rectangular solar cells are visible in this corresponding image actually, these solar cells are called as the polycrystalline solar cells. So basically polycrystalline solar cells, the various kinds of the crystal structures of the corresponding silicons over here actually, they are fused together to form one rectangular type of the solar cell actually. And that is why this technology of manufacturing is called as the polycrystalline type of the solar cells. So whenever in most of the cases in the utility scale solar project or the residential scale solar project, we try to prefer the polycrystalline type of the solar panels. So whenever we talk about the advantages of the polycrystalline type of a solar panel, one is the manufacturing process is simple actually, and that is why it is affecting on the cost of the production. So that is why the polycrystalline solar panel cost will be slightly lesser than the other kinds of the solar panel which is available in the market. So the amount of the waste silicon is less over here. It is due to the number of the silicon crystal structure they are fused together to form the polycrystalline solar cells. So that is why whatever the silicon wastage are been there actually compared to the other type of the solar panel, it should be lesser over here. Whenever we talk about the efficiency wise, efficiency of the polycrystalline type of the solar panel, it is lying from 13% up to the 16% over here actually. Whenever we talk due to the rectangular shape, the most of the incident radiation, it has been captured by the given solar cells over here. So basically, if we are talking regarding the disadvantages of these corresponding solar panels, there is a lower space efficiency over here actually. It means what? But the polycrystalline solar panels are the first generations of the solar panels actually. So that is why it is been more popular in the solar industry whenever we design the solar home systems. Due to cost point of view also, the polycrystalline solar panels are cost effective comparing to the other kinds of the solar panels over here actually. Whenever we see the next type of the solar panel, which is called as the monocrystalline type of the solar panels. So basically it is called as a monocrystalline because the cell which we are using to construct the solar panel, it is the monocrystalline solar cells. So basically in monocrystalline type of the solar cell, a single crystal structure we are using actually, which is a pure form of the boron doped crystal structure we are using for creation of the wafers of the silicons over here actually. And that is why it is called as the monocrystalline. That is a mono means the one all silicon structure we are using over here. Actually, we are not diffusing the different kinds of the crystal to form the one solar cell. It is a only one pure form of the silicon with a boron doped material we are using to create the wafers of these corresponding solar cells. So that is why this manufacturing technology what we are using for preparation of this solar cell, and that is why such panels are called as monocrystalline type of the solar cells. So basically just visual observation also we can just identify which solar panel is the monocrystalline and which is your polycrystalline type of the solar panel. Generally we are giving the octagonal shape to the monocrystalline type of the solar panel. It is due to the manufacturing process what we are using. According to that it goes the octagonal shape over here actually. In this corresponding solar cell actually this white line has been shown over here. It is called as the bus bars in the solar cell. This white line has been available in the polycrystalline also and the monocrystalline type of the solar cells also. The main role of the bus bar is to collect the current or electron hole pair whatever has been generated in the solar cell and give further the voltage or the current to the main bus bars over here actually. So that is why we require the bus bars inside the solar panels over here actually. Whenever we talk regarding the advantages wise, it is having the highest efficiency from 15 to the 20%. So the monocrystalline type of the solar panel is having the max to max efficiency up to the 20%, but generally lies between the 15 to 20% over here. They are the space efficient actually due to the octagonal type of a shape and due to the efficiency parameter has been increased. So that is why in the same space we can increase the watt peak capacity of the individual solar panels. Durability is also highest for this monocrystalline type of the solar cell and it tend to perform the better at the low light condition also. So whenever we are getting something the 200 watt of the corresponding power or radiations from the solar actually, in that situation also a slight amount of the current and voltage has been generated by the monocrystalline type of the solar cells. Whenever we talk regarding the disadvantages of the monocrystalline type of a panel, they are the expensive comparing to the polycrystalline type of a panel due to the manufacturing technology. Due to the octagonal shape, not all the incident light has been captured because in the manufacturing process, the process is such that it has got the octagonal type of a shape over here actually. So that in between there some holes has been available actually. So here whatever the solar radiations are falling, it is only captured in the octagonal shape only over here. And this will going to propagate the current and voltage to the main bus bars over here actually. But still monocrystalline type of the solar cell will be efficient comparing to the polycrystalline type of the solar panels over here. The next type of the solar panel when we talk, it is called as the half cut type of the solar cells. So basically the half cut type of the solar panels actually, there are two kinds. One is your polycrystalline type of the half cut solar panel and other is the monocrystalline type of the half cut solar panel. So basically in the half cut solar panel, a one solar cell who is having the dimension of the 165 mm by 165 mm in the utility scale type of the solar panel. So this solar cell we are just cutting into the two parts. So basically the reason of cutting the solar cell into the two parts is that we are reducing the length of travel of the current inside the solar cell actually. As good as the length of the travel of a current has been decreasing over here actually, simultaneously the heat losses inside the solar cell will going to decrease and we are getting the maximum amount of the current from the same solar cell over here actually. So that is why nowadays the new technology is coming in the market which is called as the half cut type of the solar cells. So basically when we are just talking regarding the construction of the half cut solar cell, it is slightly different than the full cut type of the solar cell like a monocrystalline and the polycrystalline. So in this case the solar cell has been used, it is the polycrystalline type of the solar cells here it has been used over here and this has been cut into the two part. Generally the utility scale type of the solar panel, it is having the 72 numbers of the solar cell having the dimensions of the 165 mm by 165 mm of each number of the solar cell. But in this case, the 72 number of a solar cell has been cut into the two parts. So we are getting total 144 number of the half cut type of the solar cells over here actually. So what we do, we just construct the 72 number of the half cut solar cell in the upper half of the solar panel, and second 72 number of the half cut solar cells in the lower half of the solar panel, and these are been connected to the central junction box over here actually. So in this diagram, these are the junction box, the positive connections we are taking out and the negative electrons we are taking out over here, and in the three junction boxes over here, the bypass diode has been located over here actually. The reason of this bypass diode location is that whenever any shadow is coming over the particular solar panel, it will just avoid that much amount of the rows over here, and it will going to give at least 50% of the power from the half cut type of the solar modules. It is only the methodology of the construction and the manufacturing process we are changing, but the solar cell will be same, that is a polycrystalline or the monocrystalline type of a technology. The fifth and popular technology which is coming in the market is called as the bifacial type of the solar panels. So basically in bifacial type of a solar panel, both the face are active for collections of the photon from the radiation which will receive by the sun actually. So let's say whatever the solar panel we are inclined at something tilt angle over here, it will going to capture the photon from the front surface also, and it will going to capture the photons by the reflected radiations of the sun rays also likewise. So in short, whatever the reflection of a light or the albedo of a light actually, it has been utilized to generate the power from the given solar cells. So in the earlier type of the solar cell, in the monocrystalline, polycrystalline and the half cut type of the panel, so basically only the one surface is active to collect the photons from the solar radiations actually. And in this case, we have a two surface active over here. So we have the N junction layer in the bifacial type of the solar panel. So that is why the bus bar which is been available, it is on the front side also, and the back side also it has been available. So the diffuse sunlight, the albedo of a sunlight or the reflection of a sunlight, it has been absorbed from the back side also. So this technology is very popular in the market, and it is a new trend in the solar panels actually, so that we can just use in the solar home system and we can get a maximum amount of the solar power. So basically, let's say if you are taking the monocrystalline type of the solar panel having the capacity of the 350 watt peak over here. So the same panel, if we are utilizing with the bifacial type of a technology with a 30% of the albedo receiving from the back side, so same solar panel from the bifacial technology with that, so we are getting this 350 power increase up to 550 watt peak also. So that is why there is a much larger potential of the bifacial technology, and which is a new trend in the solar market nowadays. So basically in this particular diagram, when we look at this bifacial solar panels actually, this is the back surface of the solar panel has been shown over here. So whatever the glass we are putting over the solar panel, from the top of the surface also we are putting one glass, and in between that we have the NPN layer, and below also we are putting the glass over here actually. So it is a reflected sunlight is also getting absorbed by this corresponding back surface of the solar panels over here actually. So nowadays in the market, the half cut type of the solar panels plus bifacial technology is also coming as a trend over here actually, which can increase the solar panel wattage capacity up to 580 watt peak also over here actually. So in that case, we can use the monocrystalline type of the solar cell plus half cut type of a technology we can use, plus bifacial technologies also we can use in the same solar panels over here. So by having the same solar cell with the same area but with the half cut and bifacial technology, we can get the maximum amount of the voltage from the same solar panel and maximum amount of the current from the same solar panel also over here.